Hello everyone. Welcome to our lesson on solving systems of equations using the elimination method. I'm Teacher Bob, and today we're going to work on a strategy that allows us to eliminate one of the variables by combining two equations. We've worked with graphing systems of equations and substitution before, but now we'll learn how to use elimination. So let's dive right in. But before we start, let's take a quick step back and remind ourselves of what a system of equations is and what it means to solve one. A system of equations is a set of two or more equations that have common variables. The goal is to find the values of these variables that satisfy all equations in the system at the same time. Solving a system means finding the values of the variables that make both equations true simultaneously. There are several methods for solving systems: graphing, substitution, and elimination. Now, today we'll focus on the elimination method. The elimination method involves combining two equations to eliminate one of the variables. And to do this, we need to ensure that the coefficients of one variable are opposites. If the coefficients aren't opposites, we can multiply one or both of the equations to make them opposites. Okay, so let's look at an example here. Here's a system of equations: 3x plus 5y is equal to 15. And the second equation is 4x subtract 2y is equal to 10. Okay, so we need to make the coefficients of either x or y in each of our equations opposites. In this case, we'll choose y. So we have a positive 5y and we have a negative 2y. So what can we do to make those terms, those y terms, opposite each other? Well, if you've got a 5 and a negative 2, if we times 5 by 2 and negative 2 by 5, we would get a positive 10 and a negative 10. That is what we're going to do with these two equations, and we're going to multiply everything out, not just our y terms. So I'm going to make the y term in the first equation 10y. So we know we have to multiply 5 by 2, so we're going to multiply the whole expression here, 3x plus 5y. And what we do to one side of the equation, we have to do to the other to maintain that equality. So we're going to multiply the right side by 2 as well. And as we've mentioned, we're going to multiply the negative 2y to get a negative 10y, and we'll do that by subtracting the whole expression here to the left of the equation by 5, and we'll do that as well to the 10 on the right. Okay, so let's rewrite these equations. So we're going to get 2 times 3x is 6x plus 10y is equal to 30 in the first equation. And for the second equation, we're we're going to multiply the terms inside the parentheses with the 5 on the outside. So we get 20x, and 5 times a negative 2 is a negative 10, and this is a y term, and that equals to 10 times 5 on the right side, so we get 50. Now what we want to do is we want to combine these two equations for our system. So we can see that the 10y and the negative 10y, they cancel out. So this is going to give us an equation with only x's in it. And we can, when we have one variable only in our equation, we can solve for the value of that variable. In this case, it's going to be 6x plus 20x, so we get 26x on the left side, and we add 30 plus 50 on the right. We end up with 26x is equal to 80. And we're going to divide 26x by 26 to isolate the x. We're going to do that to the other side of our equation. So we end up with x is equal to 80 divided by 26. And 80 divided by 26 is going to give us 3.06. So we have half of our solution. 3.06 is our x value, and now we need to figure out what y is. Well, we now, with x, knowing x, we can take that value and plug it into one of our original equations, and let's use the first one, 3x plus 5y is equal to 15. And we're going to put the x is equal to 3.06 into where the x is. So we end up eliminating, then we finish off with substituting or substitution. So it'll be 3 times 3.08. Oh, I need to put a y there. Plus 5y is equal to 15. This works out when we multiply 3 and 3.08 to 9.24 plus 5y is equal to 15. We want to subtract this 9.24 to get rid of it on the left side. We're putting our constants on the right. So negative 9.24, and we get then 5y is equal to, and when you figure that out, it's 5.76, and we can isolate the y by dividing by 5. Do that on both sides, and what do we get? We get y is equal to approximately 1.23. Okay, so we've just solved this system of equations with elimination, and our x is 3.06 and our y is 1.23, and that's our answer. Okay, now it's your turn. I would like you to solve this system of equations on your own. Pause the video, work through it, solve it, then resume the video to check your answer. So do that now. All right, welcome back. So we want to make one of our terms. We can choose an x term or a y term from either equation, and we want to make that y or x term the opposite of the same term in the other equation. And it's usually best to try and pick the easiest one to do, and I think what is the easiest to do is to make 2x into the opposite of 6x. So I'm going to multiply this expression and the 114 on the right by -3, because -3 times 2x is equal to -6x, which is the opposite of 6x. They're going to cancel each other out. And we're going to multiply the 14, positive 14 by -3. So let's rewrite these. So the first equation is going to stay the same. So 6x minus 4y is equal to 12. Sometimes you have to change both equations. Just find the most simple way to make an opposite term. So we end up with -6x minus 15y is equal to -42. All right, so we're going to combine those two equations that make up our system. The x terms cancel each other out, so we end up with -19y is equal to, well, we've got a positive 12 and a -42, so you take the larger number, larger absolute value, subtract the smaller absolute value, and your answer takes on the sign of the larger number that we turned into an absolute value. So we're going to get a -30. So let's isolate the y by dividing by 19. I'm going to divide the other side by 19. And this is so close. I'm going to actually just round it off to 1.5, and we have a negative divided by negative. That gives us a positive, and we know y is equal to 1.5. We can take that y value and we can substitute it into one of the original equations. We start off by eliminating, then this should look familiar to you. It should look, we're ending off with substitution, aren't we? So let's take the first equation, 6x, subtract 4y is equal to 12, and let's substitute y into this equation. So we get 6x subtract 4 times y is 1.5 is equal to 12. So 6x subtract 6 is equal to 12. Get rid of the constant, which is a number by itself, with an opposite operation. So we end up with 6x is equal to 18, and we want to isolate the x. So divide by 6, do that to both sides. X is equal to 6 goes into 18 3 times, doesn't it? Okay, so that's our solution with rounding off y to the 10th place value. So our solution is x is 3 and y is 1.5 or 5/10. You could put both of these x and y's values back into both of the original equations, and they will make true equations, those equations true. If you graph them, well, the point of intersection is going to be 3, 1.5. Okay, that's what elimination is all about. It ends up being the same as you would be doing with substitution, but we just start off differently. We want to eliminate one of the variables with an opposite variable, and we have to make the coefficient opposite in order to do that. All right, that's a wrap for today's lesson on elimination. Great job. If you're having trouble with any of the material that we've covered, go ahead, rewatch the video, try the practice problems again, look at the worksheet problems and answers. If you're still stuck, reach out to me. I'm here to help. Just be as specific as possible with your questions so that I can assist you better. Remember, math is a journey, and I'll be with you every step of the way. See you in the next lesson. Bye for now.